According to biblical literature, a united humanity, speaking a single language, agreed to build a tower tall enough to reach the heavens, a symbol of their divine strength, or so they thought. Angered by their arrogance, God took away their ability to understand each other. The tower was never completed, and the people were dispersed over the face of the earth. This is a story of humanity's quest to create a common language for business rules. Now let's meet the champions of humanity. Starting with the oracle. She used the stone of prophecy to predict the future. Unfortunately, she could never explain the events that led to her predictions. There was simply no way to stop them from being fulfilled. The mage was able to use a stone of enchantment to conjure giants that are capable of accomplishing any task he demands. But his giants lacked the intelligence to make decisions on their own or the ability to learn. And finally, the sage possessed the stone of wisdom, capable of solving any logical problem. Now, if only there was a way to link their powers together, we'd have intelligent, self-learning giants capable of accomplishing any task, perhaps even building a tower that can reach the heavens. And now we go to our modern day and time, where science replaces mystical powers. Let's meet our champion's direct descendants. The data scientist, who builds predictive models that feed into the machine learning process. Machine learning is pretty much a data-driven exercise. The idea is that you collect large sets of data from different sources, data that might seem unrelated or with hard to recognize patterns, and you use this data to train predictive models. So that whenever you get new data, you get a predictive outcome based on the patterns recognized in your model. An example could be detecting a fraud transaction on a credit card. So by examining a set of inputs like location, previous behavior, or customer profile, we can determine how likely it is that a transaction is fraudulent. Now, the standard to build those models is called Predictive Model Markup Language, or PMML for short. It is the de facto standard to represent predictive solutions. PMML is actually an old standard. It was released in 1999, and it makes it extremely easy for any predictive solution to be moved from one data mining system to another. While most of those models have strong predictive capability, like our oracle's prediction, they are poor at providing any justification or rationale for their output. We tend to say that they are opaque or black box models. Now, if you think of the fraud detection example, it's kind of important to be able to justify why a credit card was suspended. In fact, regulations like the General Data Protection Regulation gives European citizens the right to explanation. Article 22 of the GDPR demands that companies be able to explain to their customers how machine decisions are made. Now, our next champion is the process modeler. He is responsible for designing the processes that support business automation. The standard used to model processes is called Business Process Model and Notation, or BPMN for short. BPMN was released in 2004 by the Object Management Group, but its adoption was accelerated in 2011 with the release of version 2 of the standard, which now supported the execution of process models. BPMN uses a flowcharting technique to model business processes and automate the execution of process tasks, much like the mystical giants created by our mage. Now, if we go back to our fraud detection example, the process can be once a transaction is deemed a high risk, the process should then suspend the credit card, notify the customer, and assign the case to an agent to start the investigation. But then how do we decide if a transaction is a high risk? So this is where business rules come into play. Business rules allow a business process to take actions based on a certain logic, and it also lends its transparency to predictive models by explaining which rule conditions were triggered by the input coming from the predictive model. So what are business rules? Now, the notion of business rules goes back to the early days of expert systems in the 1970s, when companies were first trying to automate the business logic that was largely inside the heads of domain experts. A business rule provided a simple format for extracting that knowledge into a rule repo. Inference engines were then developed that could take a large set of those rules and automate their business logic. Those rules would now be available for non-expert users to read and modify through a user interface. By doing so, a BRMS bridges the gap between business and technical teams. So how does an inference engine work? First, we have the rules that we defined. Rules are often expressed as when-then statements. So when a specific condition is satisfied, then the defined action is triggered. For example, when the customer segment is standard and a transaction amount is higher than $500, then this transaction is considered a high risk of fraud. Rules are stored in a location called the production memory. The data or input provided to the inference engine is called a fact. Facts are stored in a location called the working memory. The inference engine matches those facts to the conditions of the rules stored in the production memory in a process called pattern matching. Some of the common algorithms used in pattern matching are RETI, leaps, linear, but the most advanced to date is the freak algorithm. By using algorithms, the inference engine transforms those rules into an executable decision tree. In the generated tree, every condition in our rule is transformed to a node. As we add data to the inference engine, the data is evaluated. As it flows through the tree, it reaches a leaf, which represents a rule to be fired. At this point, the inference engine activates and registers those rules in a location called the agenda. Priority of execution and conflict resolution are performed in the agenda, and then rules are finally ready to be executed by the execution engine. So why use a business rules management system? Well, a BRMS offers a clear separation of business rules from the rest of the system. So, often the business rules are hidden behind legacy systems, so when you need to modify or audit a rule, you find yourself trying to navigate a mass of hard-to-read legacy code. A kind of impossible task for a business user. So that user now has to rely on a developer who needs to be fully familiar with the legacy system to understand what needs to be implemented. The main strength behind business rules does not come from one rule or a small group of rules. Instead, it comes from a large, ever-changing group of rules that define a system so complex that it would require extensive work to maintain if it was done with regular code. By using rules, you create a knowledge base that can act as a single point of truth for business policies. Rule systems effectively provide an explanation facility. By being able to log the decisions made by the rule engine along with why the decisions were made, this becomes very important for audit and compliance requirements. Each rule models as an isolated and small portion of the business logic, and it is not part of a monolithic program, which makes rules that much easier to maintain, update, and scale. Rules are defined in a business terminology and language. So instead of having all the business logic written in legacy programming language, rules are defined in a way which is easy to understand and read by business users. This empowers business users to collaborate with IT experts and be involved in the business rule definition and modeling process. In my opinion, this is one of the most important benefits of a BRMS, one that evolved significantly over the last decade. In the early days, business teams would try and discover rules hidden in application code and then harvest them so that they could be centrally managed. The rules were then published as text-based requirement documents, which were then interpreted by programmers and converted into rules that could be coded, tested, and deployed on a business rules engine. In practice, this often had problems, because the requirements were sometimes vague or incomplete and often misinterpreted by the programmers. This is why many rule engines attempted to introduce natural and domain-specific language to define the rules. Rule engines like Drules. Drules is a modern open-source business rules management system. It is the community version or the upstream of Red Hat's Decision Manager. Red Hat's Decision Manager is an enterprise and cloud-native decision management platform. Drules uses the freak algorithm, which is battle-proven and is one of the most optimized pattern matching algorithms. This allows Drules to be fast and reliable in the evaluation of business rules. Drules also introduced the Drules language, which is a natural and domain-specific language for writing rules. Now, here is an example of our credit card fraud example written in Drules language. You'll notice that the rules are fairly easy to read by a non-technical user and follow the same structure we explained. The left-hand side of the rule defines the conditions that need to be met for the rule to be evaluated to true and trigger the right-hand side or the action. The next step in the evolution of business rules took place when the focus began to shift from evaluating rules in isolation to understanding the decisions themselves. This introduced the concept of decision modeling. A decision model is composed of the following: inputs, the information it used to evaluate the decision; structure, the elements involved in making the evaluation; logic, the means of evaluating a specific outcome; and the outcome itself. What are we trying to determine? Decision modeling breaks down large and complex decisions into smaller, more granular sub-decisions. This creates a hierarchy of a decision that is easy to read and maintain. So by shifting the focus from rules to decisions, decision modeling adds the necessary structure that was missing in the business rules approach, without letting go of its benefits. Rules are still declarative, modular, and independent, but they only have meaning in the context of a decision. On top of that, decision modeling borrows some of the well-established ideas around business process modeling, and that is, decisions, just like in a business process, should be graphically represented. This notion gave birth to the Decision Model and Notation Standard. Decision Model and Notation, DMN for short, is a standard from the Object Management Group for modeling decision logic. Like its sister standard, PMML, which describes business process logic, DMN replaces inefficient text-based decision requirements with models built by the business. DMN standardizes the decision automation from modeling to execution, meaning a DMN model can be compiled and run on a rule engine. This means that business users are no longer limited to creating model-based requirements and handing them off to developers. The DMN models they create can be verified and directly deployed and executed as a decision service. The visual representation of a model in DMN is called a Decision Requirements Diagram, or DRD for short. This diagram shows one way of modeling our credit card fraud example. Decision nodes are represented as rectangles in a DRD. Decisions represent the act of determining the answer to a business question by evaluating a set of inputs. Those inputs can come from an external data feed or be determined by other decisions. Input nodes are represented as ovals in a DRD. In DMN, decisions can be expressed using boxed expressions. So while decision requirement diagrams represent the flow of a decision model, boxed expressions define the actual decision logic of individual nodes. There are different types of boxed expressions, including literals, functions, invocations, or the simplest type in my opinion, which is a decision table. Decision tables are one of the most intuitive ways to express decision logic. The tabular nature of a decision table makes it easy to read and modify. So again, if we represent our credit card fraud example in decision table, each row represents a rule, each column is a condition, and the last column defines an action. A hit policy defines different ways to react on rule firing when the input provided satisfies the conditions for more than one rule. In this example, the U means unique. So if you provide an input to the decision table, only one rule is allowed to fire. DMN goes beyond BPMN in one important way. In addition to defining a standard graphical notation for decision logic, DMN also standardizes data and expression used in the evaluation of a decision. DMN introduced a new language called the Friendly Enough Expression Language, or FEEL for short. A FEEL expression is a formula that produces a value. FEEL was designed to be business friendly and at the same time quite powerful. I guess you can think of it as the formulas you use in an Excel sheet. The example you see in the slide is another form of box expression that uses a FEEL formula to evaluate our rule. So now it's time to see DMN in action. You can reach this online modeler by typing dmn.new in your browser. I'm going to call my DMN file high risk. And now I'm going to start creating the model. So we have two inputs. One is the customer type. And note that in FEEL, you can use spaces in your variable names. And I'm going to set the type as string. It's always good practice to set the data type DMN. And my second input is going to be the amount, and that is going to be of type number. And now I'm going to create my decision. Let's call that evaluate risk. And the result of the evaluation is going to be a Boolean. Now let's connect our input to the decision model. And then let's create our box expression. So as we've explained, the box expression can be of different types. We have literals, context, relation, function, invocation, etc. But we're going to use a decision table for today's example. And in a decision table, you can set the hit policy. So unique, first priority, etc. In this example, I'm going to keep it to the default. I'm going to set it to unique. Now let's set the conditions for a low risk transaction. So let's say if the amount is less than 500 and the customer type is standard, then the risk should be evaluated to false. And we can use this last column to describe the case. So this is a low risk transaction. And for my second rule, I'm going to define a high risk transaction where the amount is higher than 500. And the customer type is also standard. And in this case, the risk is going to be evaluated to true. And here we go. Now I've set my first rule, and I can download it as a DML file, and I can use it with any execution engine that supports the DMN. Now I could almost hear users who are proficient in BPMN cry out, wait a minute, couldn't we just have expressed this using BPMN gateways? Well, technically yes, but let's take a look at how a rule would look like if we expressed it in BPMN. It's quite obvious that it is way more verbiage to express rules in BPMN, especially if you consider that this is quite a simple rule. Now imagine modeling a rule with 5 or more conditions to evaluate. That diagram becomes too complex and hard to maintain, and it's just bad practice to do so. This is why BPMN includes a decision task to execute DMN models, and the outcome of the decision allows the subsequent gateway to route the flow. As you can see in our example, so here the gateway is only concerned about whether the transaction is of high risk or not. In DMN, business knowledge models allow the logic of a decision to be written as a reusable function that can be invoked from a decision node. Business knowledge models are expressed as a rectangle with clipped corners in a DRD, and here is where the rubber hits the road. PMML models can be invoked from a business knowledge model, and we can then use the returned result within the decision logic. A PMML-based business knowledge model is distinguished by the code P in the kind cell of its box expression. So in our fraud example, we can now include a model that takes into consideration the customer profile and the pattern of usage of his credit card transactions. Combining both standards in the decision evaluation leverages the strengths of each standard. A black box predictive model calculates risk based on historical data, and a white box decision model that can then leverage the predictive model as part of the analysis, providing explanation on that decision. With that, our champions have finally fulfilled their quest and combined the power of the 3 magical stones. And the platform that unleashes the power of the stones is Red Hat's Decision Manager. Red Hat Decision Manager is based on the Drools rule engine. It includes both the expert and fusion components of Drools project, which means that similar to Drools, Red Hat Decision Manager leverages the Freak algorithm to be ultra fast and reliable in evaluating both rules and complex event processing. If you've had some experience with rule engines, you probably already have some experience with complex event processing. In a nutshell, it allows an engine to make decisions based on streams of data as they arrive in real time. This is well suited for scenarios like stock market trading or predictive maintenance, for example. Decision Manager also supports DMN. In fact, Red Hat is one of the few vendors fully compliant with the DMN Technology Compatibility Kit for DMN 1.2, which is the latest version available for testing. Decision Manager also includes OptaPlanner. OptaPlanner is an AI constraint resolver. It optimizes planning and scheduling problems such as the vehicle routing problem, maintenance scheduling, task assignment, or cloud optimization, and many more. So the idea is you define goals and assign a limited set of resources like employees, assets, time, or money. This is evaluated under specific soft or hard constraints. So, for example, a hard constraint can be optimizing fuel, while a soft constraint can be giving drivers a break every 4 hours. Under those constraints, OptiPlanner delivers more efficient plans, which reduce costs and improve service quality. And this also plays an important role in AI. One of the highlights of the last Decision Camp conference was the keynote presented by Mike from Forrester on trends in enterprise AI and digital decisions, where he deduced a formula for pragmatic AI. Effective pragmatic AI is the combination of machine learning, constraint solving, and decision modeling. The new variable here is the constraint solver. A constraint solver in this context can be used to improve the results generated by the machine learning predictive model by analyzing the data and eliminating outliers. Outliers are extreme values that deviate from the model and reduce the overall quality of the predictive model. Now, obviously, decisioning can leverage the outcome for explainable automated decisions, as we discussed previously. So before we wrap up, there is one last point I want to clarify. We're often asked which is the better language. Is it DMN or the rules rule language? So I know in our tech talk it seemed we're implying that DMN is kind of the next step in evolution after the rules language, but in reality there are a few points to consider. So DMN supports only a subset of the rules language features and capabilities, but that's only natural because DMN was designed to create a higher level of abstraction that's more geared or more suited towards business users. And in doing so, it hides some of the more technical capabilities, but that doesn't mean you can define complex decision on logic in DMN. Rules defined in the rules language are also, to an extent, higher in execution speed when compared to rules written in DMN. So I guess the true power of DMN comes from the graphical notation and readability of the standard. I suppose the verdicts depends on who is writing the rules. Obviously, business users will find DMN much more appealing and empowering and serving the needs of their design requirements. That being said, DMN and rules are both supported by the rules rule engine and obviously Red Hat Decision Manager to cater for the needs of both business users and technical users. With that, I thank you for your time and I hope you enjoyed this webinar.